is we are going to try and solve for sine of u. So I want just sine of u, and I'm going to start with the cosine 2u. So I'm going to grab the double cosine that uses just sines. So I'm going to grab from my double angles from yesterday, the cosine formula that only involves sine. And that was our, oops, sorry. I'll fix that. There we go. So cosine of 2u equals 1 minus 2 sine squared u. That was the double angle that we wrote yesterday. Uh-huh. And so what we're going to do is we're going to solve this for sine. I want to get sine by itself. So what I'm going to do is if I want sine by itself, I need to get the 1 and the minus sign away. So I'm going to add 2 sine u to both sides and subtract cosine 2u. 2 sine squared u equals 1 minus cosine 2u. I'm just switching their spots because I want my sine to be positive. Still trying to get sine by itself. It's a u. I'll talk about what we're doing with the substitution here in just a second. We're going to divide both sides by 2 to get sine squared by itself. So we're going to have that sine squared of u equals 1 minus cosine 2u over 2. And how could I get this to just be sine? Yeah, square root it. So if we square root both sides, we're going to have that sine of u equals plus or minus. Whenever we square root something, we got to do plus or minus because we can't tell if it was positive or negative. 1 minus cosine of 2u all over 2. But we didn't really want u, we wanted some angle cut in half. So what we're going to do is we're going to take this u and we're going to substitute in v over 2. That's a v. I know it is the u-est looking v ever, but that's the font the computer uses for equations and gross. U equals v over 2 is what that says. But it doesn't let me change the font in the equations. And so the v's suck. But the v is like what we use in the formula. So we tolerate. So when we take that u and substitute in v over 2, what we get is sine of some angle over 2. So this is a half angle equals plus or minus, and I'm going to take 2 lines for it so we can see. 1 minus cosine of 2 times v over 2, so just v, over 2. So just like yesterday, we took our addition and kind of derived the formula for our doubles. We're taking our doubles and deriving the formula for halves. So sine of the half of some angle is based off of this.
Why did you take that 2 out?
Because 2 times v over 2. The 2's cancel out. Good question. Excellent question. Okay, so we're going to do the same thing to get a half angle for cosine. So we started with cosine of 2u. I'm going to start with cosine of 2u again because there's a formula that only uses cosines. And that's what we would like. So to get the cosine half angle, we're going to use the double cosine formula that just uses cosines. That was our 2 cosine squared u minus 1. So I did sine of u in purple, and I'm going to do cosine of u in this kind of blue. So we want to solve this, again, to isolate cosine. That's our goal here. So very, very similarly, I'm going to get my cosine by itself. So we're going to start with adding 1 to both sides. And I'm going to, so we're going to have cosine of 2u plus 1 equals 2 cosine squared u. And we're working to isolate this one. So if it bothers you that we're going to work right to left, flip-flop up. It makes no difference which side your equal sign's on. Trying to get cosine by himself. So we're going to divide both sides by 2. To everybody. So we're going to have cosine squared u equals cosine 2u plus 1 over 2. Same thing as the other side. We're going to square root both sides. So we're going to have plus or minus the square root of the fraction cosine 2u plus 1 over 2. And that's equaling our cosine of u. But we don't really want cosine of u. We want cosine of v over 2. We want that half angle. So we're going to substitute our v over 2 in, and I'm going to flip-flop it now so that we have this easier to read. So cosine of v over 2 is plus or minus square root, and we're going to have that the 2 canceling out again. So we're going to have our cosine 2 times v over 2, that's just v, plus 1 over 2. So we're using the double angles to find out what our formulas would be for a half angle. This is where they come from. Yes?
Explain how the 2's cancel.
The 2's are canceling out because we're taking, I'm just going to write this down over to the side, and then I'll probably erase it. 2 times v over 2. What's going to happen with those 2's? Okay. So that's what's going on both of those places where we had the 2u turn into v. So cosine of 2u, 2 times v over 2, the 2's cancel out, so we just have cosine of v. Okay. So I'm going to give us a little bit more space on the right. And I'm going to turn just so you guys have to follow my brain. Sorry. So for tangent, we're not going to start from the tangent double because ew. What we're going to do is we're going to think of tangent as sine of v over 2 over cosine of v over 2. Ooh, that's really close in. Which we just found, sine and cosine. So we can write this as plus or minus the square root of that hot mess of sine, which was 1 minus cosine v over 2. And our cosine was plus or minus the square root of 1 plus cosine v over 2. There we go. And we can simplify this because that looks like a hot mess. Everything's in the square root, so let's just make it 1 square root. So we're going to have plus or minus the square root. Since both fractions are divided by 2, what's going to happen with these denominators? They cancel out. So what we have for tangent is we're going to wind up with 1 minus cosine of v over 1 plus cosine of v. So we're going to base tangent off of the sine and cosine that we just found, which are both based off of cosine. Sorry, trying to make it so we can actually see everything, but I know it makes it very, very small. Okay, so this is where all the formulas come from, naturally. Now I'm going to show you one where it's all typed up all nice and codified. Because we can take this tangent and play with it. We could come through here and we could rationalize it because there's a square root in the bottom. Like, there's a whole lot of stuff we could do with that, but we don't want to because it's super duper gross, and I'm going to give you the formulas anyway. So these are the official formulas. These ones down here come from rationalizing our denominator, and it gives us these. So if you really want to see where those come from, you know how to rationalize denominators. Like, we can do that. I'm going to say, trust me, because it takes a long time to do it. So these are all of our half-angle formulas. We are going to use mostly these and occasionally these, but they're good to have there. Okay, so I'm going to give you a second to write those down. What's up? Well, you already have the 3 on the left. These are the ones that we found. We found these. If you play around with rationalizing this denominator, you can get it to both of these. So we did not derive these. We could, because we have awesome skills, but we're not gonna, because super gross. Like, we would have to multiply by 1 minus cosine v to get a complete and perfect square. It would be 1 minus cosine squared, which we can then switch to sine squared, which is like it's a whole thing. It's a whole thing. So if you don't want to take a picture of the whole page or rewrite all of them down, at least write down the right 2 because we didn't derive those ones. We could, but we're not gonna because it would take us most of the day, and I'd rather us practice using the formulas than rationalizing the denominator of grossness. Okay. So more often than not, when we're given a problem where we're expected to use a half-angle formula, we're just going to be given an angle and said, find it, evaluate this, tell me the value. So I was like, I'm going to give you guys a couple more seconds because I still see some people writing. It's totally fine. Because everything after this is using the formulas, not writing more formulas, because you. We're not doing 7.5, we're just going to 7.6, and I'm pretty sure 7.6 is just story problems, but honestly, I haven't gotten my copies of notes written for it yet. So, I'll have those on Monday, but I think it's just application stuff. It'll be using it in the inverses. I think, I'm not going to guarantee, but I think. Okay. So we're going to evaluate 2. I gave us all the formulas on the top right again, forgetting that freaking X in the corner. I hate that thing. Covers up the side one. And it's going to cover up the sine one on all of them. So it's cosine V underneath the squiggles. So we're going to find the exact value for the cosine of 165. So that's our first one. Cosine of 165. Is 165 on the unit circle? No. It's not. But if we play around looking at 165 for a little minute, we notice that 165 is half of 330. Is 330 on the unit circle? Is that one we know? Yeah, it sure is. So if we set, oh, it's going to fall in my brain again. Hang on. V over 2 to be 165, that means that V is 330. 330 we know. We know a lot of stuff about 330. That's on the unit circle. And since 165 is half of 330, we can use the cosine half angle to evaluate cosine of 165. Since over here we're going to use the cosine of our 330. So we're going to substitute in these values into our formula. So using our half angle formula, we're going to find out that the cosine of 165 degrees, that's our V over 2, is going to be plus or minus the square, I'm going to take 2 lines, the square root of 1 plus the cosine of 330 over 2. Not a super fan of us having that plus or minus right there. So I wonder if we can figure out if this is going to be positive or negative. Angle 165 is in what quadrant? Quadrant 2. I said 165. This guy's in quadrant 2. This is the guy we're asking about, right? He's in quadrant 2. In quadrant 2, is cosine positive or negative? Negative. So when we're looking at our formula, do we need to have the positive there? Because our cosine's going to wind up being negative. It's going to be the minus. So I'm going to put it back here so we can mark it down. So since that means cosine's going to be negative, we don't need to have the plus. So we know it's going to be negative because of what quadrant 165's in. So this is going to equal the square root of 1 plus, what is the cosine of 330? Square root of 3 over 2. And we're going to simplify this. So we're going to have 1 plus square root of 3 over 2. Well, I can common denominator that numerator to get 2 plus square root of 3 over 2. So I'd really like this to just be one fraction, not a fraction of a fraction, because ew. What's going to happen with my both over 2's? my 2 square root of 3 over 2 over 2. What's our denominator going to be when we get this down into one fraction? 4. So we have 2 plus square root of 3 over 4. Which means I can take the square root of that denominator. And we can just have our negative square root of 2 plus the square root of 3 over 2. It is still going to be best habits to not have radicals in the denominator. There's going to be times when it's super gross, so we're going to leave them there because it's the worst thing ever. But when it's possible and not super hard, like square root of 4, we're going to rationalize or simplify. Between the 2's? Because it's square root of 2 over 2. So we have the negative square root of 2 plus square root of 3 that are all under a radical. So that 3 is getting square rooted twice, which is super gross. Okay, so we're going to split things apart and evaluate them individually. And I'm going to give us a blank page to do this again. Got that? Okay. All right, so now we're going to look at this sine of 105. And I'm just going to give us some blank space. There we go. Sine of 105. So again, I don't know 105 off the top of my head. That's not one of the things we know. But if we notice that 105 is half of something we do know, 210. So if V over 2 is 105, V is 210. And that's something we do know. 105 is in which quadrant? 2. So is the sign going to be positive or negative? Positive. In quadrant 2, sign is positive. Remember, signs are y's. That's still above our x-axis, so our signs are still positive. So when we're filling in our formula for our half angle, we only need the positive one. So when we're filling in that half angle formula, we're going to wind up with the sine of, and we're using our 105 as our V over 2. It's going to equal just the positive, because we already know it's in quadrant 2, square root of 1 minus the cosine of V, so cosine of 210 over 2. So we're going to simplify this. The 1 is just coming down. What is the cosine of 210? Negative square root of 3 over 2. And then again, we're over 2 again. So we're going to simplify the top, get to a common denominator within that numerator, because we have fractions upon fractions. So that's going to give us 2 plus the square root of 3 over 2 all over 2. Yes, dear?
How did you get to?
I took this 1 times 2 over 2 so that we got to a common denominator. Okay, see it? Oop. Yeah, we're just taking this numerator and getting it to a common denominator. My 2 negatives became a plus. When we take our 2 plus square root of 3 over 2 and divide it in half, what's our new denominator? Like when we simplify this, the fraction divided by 2. It's going to be 4 in the denominator. If it helps, you can also write it out. I'll write it over here. As the multiplication style, 2 plus square root of 3 over 2 times 1/2, if that helps us spot what's going on here. So that we wind up with 2 plus square root of 3 over 4, which again, we can simplify that denominator because it's a square root of 4, and we just have our square root of 2 plus square root of 3 over 2. On our sines and cosines, we're almost always going to be able to get a denominator that's a whole number. Almost always 2. But sine and cosine will be able to get a nice denominator. In tangents, we won't always be able to get a nice denominator, and that's okay. Sometimes we will, but sometimes it's going to be super gross and we're just going to not fight it. So let's go play with our tangents a little bit so that we can see them. And we're going to find tangent of 22.5. .5, we know definitely is not on the unit circle because there's no decimals. I know definitely I can't find any product or sum that's going to wind up with that because we're, decimals and grossness. So we know for sure this is going to have to be the double angle, or the half angles here, where V over 2 is 22.5, which means what's the V going to be? 45. So we're looking for the half angle of 45. And we can use any of these tangent formulas. These all mean the same things. This is the one we derived. You don't have to use this one, but you absolutely can. This means we only have to figure out cosine. Or you can do this one, or you can do this one. It genuinely does not matter to me which one you use. I was like, if this one gives you the most probability of gross denominators, but it's also the one we saw kind of be born. So I don't really care which one we use. So I'm going to do this one. I'm going to do this one, the one that we derived, just because we kind of know where he's from. But just as a warning, we're going to have a gross denominator, and that's okay. So that means we need to know cosine of V. So what is the cosine of 45? Square root of 2 over 2. What quadrant is 22.5 in? 1. So is tangent going to be positive or negative? Positive, because everything's positive in quadrant 1. What's that? Yeah, let me write you pass. So we are going to take our formula and we're going to substitute our values in. Tangent of our 22.5. And again, I'm going to use the kind of gross one that's just got cosines in it. So I'm going to have my 1 minus my cosine,
which is square root of 2 over 2. And we're going to have our 1 plus our cosine, which is square root of 2 over 2. So when we're simplifying this, I'm going to take my numerator and my denominator and get them to be one fraction so that we can combine these. So my numerator is going to be, when I multiply that 1 by 2 over 2 to get common denominators, 2 minus the square root of 2 over 2, gross, and 2 plus square root of 2 over 2. Super gross, fractions of fractions. We've seen this before when we have two fractions that are being divided by the same thing. This over 2 is going to cancel out. So our answer is actually going to be, and we're going to leave it like this just because it's super duper gross, 2 minus the square root of 2 over 2 plus the square root of 2. And when we have a fraction that has the square root of a square root in the denominator, I'm going to say that's your sign to leave it be. We're going to leave it. We're not going to rationalize it because we would have to rationalize twice to make it truly not have a radical in the denominator, and it's going to be super gross. So if you have a radical of a radical in your denominator, leave it be. Even the textbook leaves those in the answer keys. Okay? So if you have a radical of a radical in your denominator, do not bother trying to rationalize. Okay? If you just have one radical, we can do it. But when there's two radicals, that is doing too much. Okay? If it bothers you to have that, you can use one of the other formulas. These ones will have a lower chance of double radical situations. But I wanted us to practice with the one that we kind of derived as opposed to the ones that showed up by magic. Because sometimes that's what it feels like. Okay? So these are weird a little bit. And in the book, they give you a lot of the ones that are structured like this, which are exactly like how we did them yesterday, where we figure out which quadrant it's in. So I don't know that we'll have time to do the whole thing, but I want to talk through pieces of it so that we're aware when it comes to the homework. So what quadrant is this one going to be in? 2. Which means our signs are what? Positive or negative? Sine's positive, cosine is negative, which means tangent is going to be negative. So we know that this guy's negative, which means when we're picking a formula, we only need to use the minus sign. Okay? So they're giving us the cosine and asking us to find theta over 2. You have options. You can, since they gave us cosine, just use the formula that uses cosine and not have to draw the triangle. You can also come in here and just like we did yesterday, make yourself a little sketchy sketch in quadrant 2, figure out all your pieces, and find your own sine of v. Okay? So you have options. Yes, dear?
We use like the formulas we did yesterday first and then...
Not the formulas, like how we did it where we drew the little triangle and we figured out our missing pieces.
Yeah, but you said like since we are given cosine, you don't have to draw the triangle.
You don't have to. You can just use this guy because that one only needs cosine. Because we're asked to find tangent of theta over 2. So that means I need this one is going to be theta. So we know cosine of theta. So we know cosine of v. So this is our theta, and that's our theta. So you can use this one and just substitute it in there.
Is it because this is a half angle and not a double?
Because it's a half angle, not a double angle. Yes, dear.
How did you know it was involved?
Since it's bigger than pi, or pi over 2 is smaller than theta, and pi is bigger. If we think about our unit circle, this is pi over 2, and this is pi. So we know our angle is somewhere between those two. Since theta is between pi over 2 and pi. It's somewhere over here, which is quadrant 2. Okay, so they're going to give you a trig function and ask you to find the half angle. And you have options on these. But I also don't want us to be like trying to rush through and fly through all the way to the end. Okay, so they're going to give them to you more like this as opposed to the straight up numbers, but some of them are just going to be straight up numbers. And we'll continue working with these half angles and the double angles next week, but I also don't want to like run us up to the wall on time. Okay, so we are going to have a quiz on Wednesday of next week. Just saying. Mm-hmm. Which one is that?
The 6.4 homework.
6.4. Let me make sure I have it in here. Fixed. Thanks, Billsy. That's part of the reason I give them back to you, so you'll double check me on that stuff. Also, today's the last day for the challenge problem. It is changing today, and I'm taking all the cookies home and eating the rest of them. So if you want a cookie, you got to give it today.
Do you have a stapler?
A stapler? Yeah. Yep. If you want the cookie, give it to me. If you don't want the cookie, you can put it in the turn-in bin. Let's see. There you go. Cookie. Leslie.
Oh, you got it.
Here's your cookie.
Thank you.
And Arizona.